Hello, so today we are going to do this problem, which is called determine if two strings are close, which is part of daily Leetcode daily challenge for December 2nd. So the problem says we have two strings and we want to check if they are close. And two strings are close if we can do one of these two operations to make the first one, word 1, equal to word 2. And the two operations are swapping one character, so like this, swapping the order here, or the second one is for every occurrence of one character, exchange it with the other. So basically all A's to B's and all B's to A's, right? So for example here, what we can do is we can exchange B and C, exchange to do the first operation, so we get ACB. And then after that, we want to exchange A and B, so we get BCA, which is the word here, so we're going to return true. Here it's not possible, right? Because one character occurs once, the other occurs twice, so it's not even possible, right? So let's take a look. How can we do this? So the first observation, right, is that if a character is in word 1 and is in one word and not in the other, right, then it's not possible, right? Because we do not add any extra character. And the other, then not possible, right? But the other thing is that if you have a character in word 1 that occurs 3 times, we need to have another character that occurs 3 times in word 2. It doesn't have to be the same character though, because remember we exchanged the characters here. So this, we need a character, same or different. If it's same, we don't need to exchange. Sorry. We can do the swapping, but if it's not the same, then we will need to do the exchange here. We need a character, doesn't need to be the same, with the same number of occurrence, right? Let me take an example here. So for example here, let's say word 1 is equal to this. And let's say word 2 is equal to here, for example, right? So you can see here A occurred 4 times. Or even actually we can just take this one because A 3 times. Yeah, we can take the example we have here, right? So A occurred 3 times. Here A occurred 2 times, but we have B 2 times, and we have let me just make sure this is correct, like this. So B 2 times, A 2 times, here B 3 times, and C once, and here C once, right? So if we apply the second operation, which is exchanging, then all the A's with B's, so we would get B, B, C, B, and all the A's with B's, or the B's with A and A with B's, right? So we get the exact same character, right? And you can see the number of occurrences is not the same. But what we really need is this. If B was only 2 characters, then it won't be possible, right? So we need these to be equal. We need to have at least one. We need to have one that has the same number of occurrences. Similar thing with these two here, right? Because otherwise we would not be able to change these B's to get these A's, right? And C here is already equal, so no problem. But if we had X here, then it won't be possible because we can't add another character, right? So that's also like that's the first condition. And here, for example, if we take a look, comparing word 1 and word 2 here with the second example, so this one is word 1 and this one is word 2. You can see E occurred once, B once, D once, C once, A once, right? So this one, all of them occur once, so we can either swap or we can exchange each one with another one and get the desired behavior. So for example, we can exchange B with E. So this becomes here, this becomes here, and now we have the solution, right? So what matters is having, if there is an count of occurrence, we need the same. So how do we do this? Well, we can just collect the values. So here the values are 3, 2, 1, and here the values are 3, 2, 1. And we can just sort and make sure they are equal. So if we sort here, so here the values are actually 2, 3, 1. So we can just sort and we get here 1, 2, 3. and sort here, we get 1, 2, 3, and just make sure they are equal. Because if we sort and they are equal, that means every count of occurrence has the same one count here, right? And that should give us the result. And if there is, let's say, x, for example, here, then we will get x1, so we'll get another one here, so we'll get another one here, and they won't be equal, so it will return false. So it will also verify the first condition. Okay? Except one problem is that what if they are all different, right? What if we have w1, let's say maybe it's equal to xau or xab, and then w2 is like zwn, something like this, right? So that we get x is 1, a is 1, b is 1, and then here we will get z is 1, w is 1, n is 1, right? And now we would have, once we get the values and sort, we'd have these values, and they are the same. But the problem is that this is not right. So we want to also check that the first condition here, we want to check it separately. So we want to check the sorted occurrences are equal, but we also want to check that there is no character that is not here, right? So that's the gist of the solution. Now let's just implement it. So we need the occurrences. So let's get the occurrences for the first one. For word 1, get the occurrences for word 2. And we know that we want to check the sorted for this condition here. So we want to check that sorted of the values of 1 is equal to the sorted of the values of 2. Okay, and then the second thing we want to check is this here, that there is no character in one that is not in the other, so that we don't end up with something like this. And you can imagine here, maybe even like, it doesn't have to be all of them different. We could have maybe something like this. Let's say this is D, right? We would have 1 and then 1, 1 and then 2. 1, 1 and then 2, and they would still be equal, but these are not valid. We can still exchange these two, so that works, but these two are not, right? So we want to check if there is, for every character maybe in word 1, we want to check, make sure it's in word 2, right? So C, if it's equal to 0, it's not, then we have a problem, so we're going to return false. We can't exchange. And you could also just change this to make it slightly nicer with checking any. Here, if there is any for C in word 1, if there is any one that is equal to 0, then we want to return false. Okay, and so that should work. Let's submit. And that passes. In terms of time here, occurrence can be at most like the number of characters. I don't know if they said like we have lowercase or not. Let's see, yep, we have only lowercase English letters, so we have up to 26 characters. So occurrence here would have up to 26 entries, right? So definitely in terms of space, we have O of 26, which is constant. In terms of time, we are doing this sort on also values, which can be up to 26 as well, because each character has just one entry. We are sorting, so that's also of 26, log of 26, so almost constant, right? It's pretty much constant, right? So should be pretty fast. Yeah, so that's pretty much it for today's problem. Please like and subscribe, and see you on the next one. Bye.